Hi, my name is Sarah Anderson, and I'm a PhD candidate here at the University of Calgary. There are so many resources to teach anatomy today. Our goal as instructors is to balance the use of all these resources and to target our instructional methods to optimize the efficiency of student learning. This because formal instruction time in anatomy has reduced in the medical curricula. I'm interested in examining when and how best do we use different anatomical representations to teach anatomy. Today I'd like to share with you some of our research examining learning with two-dimensional representations using a reinforcement learning task for the purpose of building foundational knowledge. The objective of this study was to design a reinforcement learning task in which participants successfully learned to identify neuroanatomical structures in a time-efficient manner. We predicted that the provision of immediate feedback would activate reinforcement learning mechanisms within the brain, thus enhancing knowledge acquisition in novice learners, such that performance accuracy, in this case, correct identification of your neuroanatomical structures, improves by task completion. We recruited 10 participants from health-related programs at the University of Calgary who are expected to have minimal neuroanatomical knowledge. In this task, these 10 participants learned to identify neuroanatomical structures shown using two-dimensional coronal brain images over the course of 320 trials, separated into blocks of 20. We found that following task completion, there was a significant increase in performance on the identification test. In this case, mean performance increased from 4% to 94%, and the range of scores on this test was between 75 and 100%. We also examined the learning curve of each participant as they completed the task. Using repeated measures ANOVA, a significant effect was observed for task performance as the task progressed and demonstrated a large effect size. Specifically, a significant improvement was observed from the first to fourth block, and by block 13, or 260 trials, participant mean accuracy consistently exceeded 90%. The total task duration was approximately 30 to 35 minutes, with all participants reaching proficiency again by 25 to 30 minutes. Our results highlight the key role of reinforcement learning approaches to establishing foundational knowledge in the preclinical sciences, specifically anatomy, in a time-efficient manner. Also, learning curves generated from these types of tasks can be used by instructors to monitor student performance. This fall, we will be examining the efficacy of use of reinforcement learning tasks, such as this one, using different anatomical representations as pre-class exercises for specific lectures. Finally, since this task has been designed to be compatible with measurement of neurophysiological data by electroencephalography, future work will assess the neural correlates of learning using different anatomical representations by measurement of event-related potentials. Thank you for your interest in our research, and feel free to contact me with any questions. I hope you enjoy the rest of the AMEE conference this year in Glasgow. Thanks.